Welcome back to Beyond. Today we'll be looking at Indices and Index Laws at AS level and Year 1 of A level. You will need prior knowledge of GCSE Indices and Algebraic Simplification to help prepare you for this lesson. So let's get going. Indices are a way of showing that we're taking something, a constant, variable or expression, and raising it to a power, finding its root, or taking its reciprocal. A positive integer index is an instruction to multiply the base number by itself, where the index gives the number of bases to multiply. For example, a to the power of 5 means a times a times a times a times a. X plus 4 all cubed means x plus 4 times x plus 4 times x plus 4. An index of -1 represents a reciprocal. For example, 5 to the power of -1 is just simply 1 over 5, or 1/5. 3x plus 2, all to the power of -1, equals 1 over 3x plus 2. Or, in more general terms, a to the power of -n equals 1 over a to the power of n. A fractional index with a numerator of 1 represents a root. So, for example, 27 to the power of 1/3 equals the cube root of 27, which is just 3. Or 4x squared, all to the power of a half, is equal to the square root of 4x squared, which is positive or negative 2x. Remember, when we're doing the square root, we can have a positive answer or a negative answer. In more general terms, we can say that a to the power of b over c equals the cth root of a to the power of b. The cth root just means a little c in that square root sign, similar to a cube root or the fourth root. These can be combined in any form, so a power of -3 over 2 would represent taking the reciprocal because it's negative, cubing because the numerator is 3, and square rooting because the denominator is 2. The order in which you perform these operations won't affect the result, but it may affect the difficulty. Sometimes it's easier to square root first, sometimes it might be easier to cube first. So let's look at a question together. Example 1 asks us to write the following expression in the form x minus a to the power of b, where x is not equal to a and b is any rational number. And the expression we're given is 1 over the cube root of x squared minus 6x plus 9. We can start by factorising the expression in the denominator. So we have x squared minus 6x plus 9. We know from GCSE that just factorises to x minus 3 all squared. You could also write it as x minus 3, but x minus 3 all squared is in the format that we want. Putting this back into the denominator gives us 1 over the cube root of x minus 3 squared. We know that a to the power of b over c equals the cth root of a to the power of b. So we can write that expression as 1 over x minus 3 to the power of 2/3, or 2 over 3. Finally, we know that a to the power of -n is equal to 1 over a to the power n. So reversing that means that we have x minus 3 to the power of minus 2/3. So altogether, we have 1 over the cube root of x squared minus 6x plus 9 equals x minus 3 to the power of -2 over 3. Now let's work together on another example. Given that 4 to the power of 5 multiplied by 8 to the power of 3 equals 2 to the power of x, find the value of x. The key thing here is to break it down into different powers of 2. So we know that 4 is equal to 2 squared, or 2 to the power of 2, and that 8 is equal to 2 cubed, or 2 to the power of 3. Replacing these numbers in our original equation gives us 2 to the power of 2 to the power of 5 multiplied by 2 to the power of 3 to the power of 3, and that's equal to 2 to the power of x. We can multiply each of those powers to give 2 to the power of 10 multiplied by 2 to the power of 9 equals 2 to the power of x. Finally, we can add those two powers to get 2 to the power of 19 equals 2 to the power of x, so x must be 19. For more practice questions, follow the lesson link in the description below and let us know how you do in the comments. Thanks for watching, and don't forget to like and subscribe, and we will see you next time. Bye!